In this video, we're going to begin our exploration of how to implement behavior-driven design in a Spring Boot application. So to start with, I need to have some requirements, and I put this as part of my requirements document here. I need to have a few requirements that are stated and have examples elaborated in given when then syntax. And then I can take those and I can make a unit test out of them. Let's take a look at a couple of cases here. So, as a homeowner, I want to be able to catalog my plants so that I will remember what I planted. Given user is logged into my plant diary, when the user searches for Eastern Redbud, when the user adds text details about the Eastern Redbud, then the user's Eastern Redbud will be saved. So a couple things. I've thought about breaking up this test a little bit. First of all, I'm not going to worry much about login just yet. If you start a project and all you're worried about is the login screen, by the end of 15 weeks, all that you might have in your project is the login screen. So nonetheless, might put that one on the back burner. Also, a couple things we want to consider is, where are we going to get the plant data? Where's it going to come in? Okay, how do we confirm that the redbud was successfully saved or not? So a few considerations there. We also have, given user is logged into my plant diary, when the user searches for just jumbled text, then my plant diary will not return any results. This one will probably be the simplest given when then to start with. So we can start with that one and we can eventually move on to some of the others in here. Now, just a reminder of what we're testing. A true unit test should only really test one class. So this is a class diagram we put together a while ago. We see there's this My Plant Diary DTO layer. I'm going to go ahead and add another item here, which is plant. So I actually don't know if yeah, okay, that'll work. So I'm adding a plant here as a, let me get rid of this guy. I'm adding a plant here as yet another DTO because this is data that we might get from an external source. Could be internal, could be external as well. Also, I'll need some way to look up that plant, but nonetheless. So we are going to focus our behavior-driven design test in the service layer. You could make an argument that we could pop it up to the controller layer, especially with Spring Boot. That's a conversation for a different video. Right now, we're just going to look at this controller layer, or the service layer right here. It has an interface, Specimen DAO, and then a stub, which is going to be just a hard-coded representation of what we will eventually have. And then it will have the eventual implementation, which is going to come a little bit down the road. Now, normally with behavior-driven design, we would not start with source code that's already there, but in this case, I did create the interface, Specimen Service, in a previous video, and I also created an implementation of that in a previous video. So we'll assume those are there, but nonetheless, we normally wouldn't even have those. So I'm going to navigate to my project, the source test Java location, right-click and say New, and Class, and we will just call this Specimen Service Test, or Test Specimen Service, something like that. In JUnit 3, we had to add the word test into a class name. JUnit 4, we don't have to, but many times we do anyway. So I go ahead and choose Finish. Okay, now we know that we already have a starting point here because we've defined some of our given when thens. So we could take a look at this one and remember that what we're testing for is essentially no results found. So we could call this test something like validate. What we need to think of a method name. So we could make a method called fetch plants, for instance. Fetch. Now, again, the difference between a plant and a specimen. A plant is the scientific definition of a plant, like its Latin name, where a specimen is a physical plant that you can touch. So we're within the specimen service, but we might have some kind of like fetch plants lookup that's going out and it's fetching these scientific definitions from another source. So this method could be called fetch plants underscore test junk data or something like that. Typically, when we're doing behavior-driven design, we do like to have verbose method names that include what we're testing, as in what method we're testing, and what data we're pushing into that test. So make a method here, public void. We'll say fetch plants validate no results for junk data. So you see, that's a tremendously long method name by Java standards. And also it includes an underscore, but that's kind of common. So here's the method that we're testing, and here is what we're actually testing. No results for junk data. Okay, good. So we need to have a specimen service. So I'm going to say iSpecimen service, specimen service, just like so. And as I say, a lot of times we wouldn't automatically have this iSpecimen service, but I have already created it, so I'll go ahead and import it. Now, within our fetch plants, we should have a couple things. First of all, we need to put the @test annotation above it. Remember what that is. So put the @test annotation above it. Next, we need to make methods that match the given when and then. So given user is logged into my plant diary, let's go ahead and make that method. Given user is logged in to my plant diary. And notice I'm writing methods that don't yet exist. Actually, while I see it, let me go ahead and import test. That's one we can, that's one that we can take care of there. There we go. Okay, when the user searches for, we'll just call that junk because it contains illegal characters. So when the user, searches for junk, okay, and then we'll say, okay, then my plant diary will not return any results. So we'll say, then my plant diary returns 0 results. So again, you see very verbose method names. Now, here's the thing. You see, I'm calling methods that don't yet exist. There's a little shortcut we can take to have Eclipse generate these methods, but one note, it's easiest to start from the bottom and work up. Reason being, whatever method you generate, Eclipse just automatically puts it right after the method you're already in. If you start from the top and go down, they actually end up being in reverse order. If that doesn't make a lot of sense, just watch what I do here. I click on the plus and I say create method. Take a look at where it created this method. It created it immediately underneath the method where we currently are. Now I'm going to go to when the user searches for junk, and we mouse over and we say create method, and now take a look at where that created it. It created it above the then method that we created previously, but after the fetch plants method that we're in right now. So yeah, we're good with this proposal. We'll go ahead and let that go. Given user is logged into my plant diary, I click create method, and you see that one gets created. So now because I started from the bottom and worked up, they were created in the necessary order. So the given part I mentioned, not worried about just yet, because we're going to assume that this user is logged in. When the user searches for junk, this one's going to get a bit more interesting, as is the then part. So when the user searches for junk, well, I want to use this specimen service that I've declared above. And so I'm going to invoke fetch plants. And now what's my search term for fetch plants? Well, it's this weird thing right here. And unfortunately, with my virtual machine, my clipboard isn't bidirectional. So I can't just copy and paste this in. I will do my best to replicate it, but notice when the user searches for KAJSD, so on and so forth. So we'll go ahead and say I'm going to search for KAJSD, semicolon, LUAOPUIDFJO, semicolon, AJ, semicolon, SD. So that matches pretty closely what my given was. Now, you're going to itch a little bit here as I am. There is no method called fetch plants, and kind of that's the whole point. There's no method called fetch plants. So we're going to need to make one to get this test to pass. So let's say that this method is going to return a list of plant objects, and guess what? We'll call it plant DTO. There's no class called plant DTO. So that's another thing we're going to need to make. So you see, writing this unit test, we start realizing everything that we're going to need to make. So we'll call this plants equals specimen service.fetch plants. But really, this guy should be shared across different methods. So I'm going to promote him up and make him an attribute. We'll just say plants equals specimen service.fetch plants, just like so. And those two are one and the same. We go ahead and choose save. Okay, now we have the then part. The then part is my plant diary will not return any results, and the user will not be able to save the plan. I'm just going to worry about the 0 results part because that's going to be the easiest for us to test. So for this, I'm going to say assert. We can do this several different ways. Really, we just want to look at the size of this list of plants that gets returned. So I could say assert equals, let's say message, no plants, or number of plants returned. So that's an optional. You can start with a string, which is a message. Then we're going to say 0, and then we're going to say plants dot, this is a list, so it should be plants dot size, like so, and terminate with the semicolon. And save. Now, we see from the red lines, we know what we need to do to get this test to pass, and we know what we need to do then to accomplish our task here. What we would typically do at this point is we would, number one, run the test and confirm it returns red, because if the test returns red, we have more work to do. It's not even going to compile because we have compile issues, so if I right-click and I choose Run as JUnit test, it's probably going to look at me and say, huh? So we need to get it to compile, number one. So first of all, go back to our test. If we didn't have it already, we would need to make this interface, but as I said, that's already done. So pretend that this guy has a red line under it and pretend that we just made the interface. Okay, the next thing we need to do is we need to figure out what this plant DTO is going to look like. Now that one's fairly straightforward, because if you take a look at this JSON stream that we have here, you can see that this will be the source of our data. ID, genus, species, cultivar, and common, those are essentially what make up a plant DTO. So that one's going to be fairly easy to do. Let's go ahead and do it. I go to my DTOs here, right-click and choose New, and choose Class, and we'll just make a quick and dirty plant DTO, and then finish. Okay, for our plant DTO, I say private. Int GUID, so kind of like a global unique identifier, private string genus, private string species, private string cultivar, and private string common. Okay, right click, and we'll say source. And we will say generate getters and setters and select all. Let's put it after common is good, and generate, and boom. And probably want to add a bit of JavaDoc to this, but nonetheless, we now have a plant DTO. Let's go back to our specimen service test and see if we have more options here. And indeed we do. Import plant DTO. And you see now that red line goes away. Okay, what's next? Next, what about this fetch plants method? It looks like we have a fetch plants method we're not really clear on. But I do want to point out before we get to that, we have another thing that got resolved. This was a red line earlier because it didn't know what the plants collection was, because it didn't know what a plant DTO was. And so that has been resolved, and now it tells me I don't know what assert equals is, but that's an easy fix. We just need to add a static import for that. Takes care of that. Okay, at this point, we just need to fill in this fetch plants method. So what I would typically do at this point is I would go to the interface and also the implementing class, and I would add the fetch plants method manually. Eclipse can help us out here though, and let's take advantage of that. Because notice that it says, hey, there's no fetch plants method in this specimen service interface. Do you want to create one? And I'll say, yeah, I do. I want to create one. So I say create, and notice that it goes over to the interface, and how does it know which one? Well, it's the variable type we're declaring on line number 14. So it runs over to that interface and it makes a proposal for a fetch plants method. And I'll say, I'll add some JavaDoc here that says, here we go, return a list of plants that contain this string. Okay, param string, let's say the search criteria can be genus, species, cultivar, or common. Okay, return a list of matching plants. So you see, now our interface is up to date, and our interface has this method. Remember, though, that when we implement an interface, we're under contract to provide an implementation for each of these methods. We're currently implementing this interface with one class, and that class is our specimen service. So I'm going to go to, just one moment, go to our specimen service. And right now we're just stubbing things out. You might remember we started creating this several videos ago. We're just stubbing things out so that we can fulfill our contract and let our user experience person know what calls to make down to us. Meanwhile, in the service layer, we can keep building as the user interface person is working in parallel and writing that user interface. So you notice that I have a compiler now. I click here, and what does it say? It says, I have a method that's not implemented. And what is that method? Well, guess what? It's our fetch plants method. So what we need to do here is, again, this is just a little dummy thing that we can mock up. So what I can do is I can do a little bit of mock-up, and I'll do this kind of quick and dirty. So stub out a plant fetch mechanism. Okay, so we will say if, let's say string, we'll call the search term, so it's a little more descriptive. Now we'll say if search term, we'll say dot contains, and then we could say redbud, or let's just say edbud, so we don't have to worry about capitalization. So if search term contains edbud, or search term contains Cercis, which is the Cercis is the genus for redbud. We'll just leave it at that. Then what we'll do is we will create a new redbud plant. Remember, this is just a quick and dirty mock-up, so not the actual implementation. So we'll say plant DTO, plant equals new plant DTO. Okay, and then we'll say plant dot set genus Cercis, plant dot set species Canadensis, plant dot set common Eastern redbud, plant dot set cultivar. We won't worry about cultivar for that. That's good enough. But we know we can't just return an individual plant. We have to return a collection of plants. So I'll say list matching plants, and we need to add a generic identifier on that. So list plant DTO matching plants equals new array list plant DTO again, and boom, like so. Okay, and let's take care of a couple of imports here. There we go. And looks like I have a little capitalization issue here, so let's take care of that, and we're all good. Now we'll say matching plants dot add plant. Okay, and then finally we will return matching plants. So ideally this would actually hit the live JSON service that we have over here, but there again we know we don't know how to do that yet. It's not really hard, but we don't know how to do it yet. So we just want to return some predictable output. If the user does not pass in edbud or Cercis or some combination of that, then matching plants is going to be empty, which essentially is our test criteria. So I go ahead and save, and you see this compiles. Now let's go back to our test class and take a look. Everything compiles. Now this is Spring, so we do have to add a few annotations here. First of all, we have to tell it it's a Spring Boot test, and so use all the Spring work niceties. We also have to tell it what our test runner is. In our case, we're just going to use this SpringRunner.class. In addition, we want to take a look at our build file, our POM, and make sure that we have Spring Boot Starter Test, which is what we're going to use in our case, because that includes a whole bunch of useful stuff. JUnit, Spring Test, AssertJ, Mockito. We're going to use JUnit, Spring Test, and Mockito. There are several others that you can use here. So Spring Boot Starter Test kind of comes pre-packaged with some of the most common libraries that we're going to use in unit testing. So back to our test now. Let's go ahead and say at run with, and we'll say SpringRunner.class, and then we will say at Spring Boot Test. And with a lot of annotations, Spring Boot Test has several properties that we can specify. You notice that we need to do a bit of work here because it says I don't know who all these things are. So import run with, we got that. And import SpringRunner, got that. And then Spring Boot Test, we'll go ahead and say import that. Also, guess what? Because it is Spring Boot, this is really cool. We can auto-wire this dependency. Now you might say, but how do I know which one gets auto-wired? There's an annotation called test config where you can specify this to make sure you're actually testing against the right class. But nonetheless, run with SpringRunner, Spring Boot Test. That sets up all the Spring Boot framework for our test, and then AutoWired works as it always has. Just a quick peek at my POM, make sure that my POM looks good. So we go to our POM XML, and sure enough, in the POM, we see Spring Boot Starter Test is right here. So I have that kind of meta library that includes a bunch of other libraries. So let's go back now, just a quick second look at our test to make sure everything looks good, and I think it does. And we have our assert equals here. So let's right-click, run as, unit test. And in this case, it's starting a bit of the Spring framework. It's a little tricky because you can sit here and look and you don't see what you want to see. But go over to the JUnit pane, and now you see that sure enough, this test did execute as expected. If I were to, let's say that I change the test to force it to fail, maybe let's say I'm expecting 1, and of course we know this isn't the case. I just want to show to you that the test did indeed run. So we do 1, and then we do run as, and we'll say JUnit test one more time. And this time I'm expecting a failure. So I go over to the JUnit pane, and what do we say? What do we see here? Fetch plants, and we see a red bar this time. Number of plants expected 1, but was 0. So we'll go ahead and collapse that again. We know that that was not the actual test we want to run, so we'll go ahead and fix this. At this point, with it fixed, we do have a unit test that we wrote using test-driven design principles and behavior-driven design principles. We started in a state where it couldn't even compile. We made a compile. Then it wouldn't run. It wouldn't pass because we didn't have all our necessary criteria in. Now we see we have a passing test. Now we know we had to mock some things up and dummy some things up, but if we go back to our class diagram, we know that we now have our test passing against this hard-coded stub, so we know that we now have a certified test, or a test that we know will test out this actual implementation when that implementation is ready. So at this point, we can start building this actual implementation class, and as soon as our unit test turns green, we know we're in good shape. Now, of course, that's not the whole story because we didn't cover every single given when then, but nonetheless, you understand the pattern now. We simply have to replicate all of the other given when thens from our requirements document, and we have to make sure that we have that we have those properly elaborated, so we're covering everything. Put those into our unit test, and then make the unit test compile, make the unit test turn green, and at that point we know once the unit test turns green, we know that we have accomplished test-driven design. So that's a look at test-driven design. Stay tuned. I also want to talk in a future video about mock objects. I look forward to seeing you then. Thank you.